In this video, we're going to work through a limit proof for a quadratic function. The limit is limit as x approaches 4 of 3x squared minus x plus 1 equals 45. Again, just as a reminder, here's what we're showing. Given any epsilon greater than 0, there exists a delta greater than 0 such that if 0 is less than the absolute value of x minus 4 is less than delta, then 3x squared minus x plus 1 minus 45 absolute value is less than epsilon. Let's do some scratch work, beginning with 3x squared minus x plus 1 minus 45. Let's simplify this and see what we can extract from it. That simplifies to absolute value of 3x squared minus x minus 44. Now, of course, if we substitute 4 into 3x squared minus x plus 1, we do get 45. Therefore, of course, if we take 3x squared minus x plus 1 and subtract 45, which is the 3x squared minus x minus 44, x equals 4 will be a 0 of that function. Okay, what that means is x minus 4 must be a factor of 3x squared minus x minus 44. So in fact, that does a little bit of the factoring for us. We know now that 3x squared minus x minus 44 has to factor. It has to factor into x minus 4 times, well, what is the other factor? It would have to be 3x, and we'd have to have a plus 11. Checking that, we see that is how 3x squared minus x minus 44 factors. Now, again, by the assumption that we're eventually going to make in our formal proof, we know that that absolute value of x minus 4 will be less than delta, which will leave us with delta times absolute value of 3x plus 11. Now, here's where we're going to do our little trick that we discussed in class. I'm going to suppose that whatever delta we end up choosing eventually, that delta will be less than 1. Now, if that's the case, assuming that the absolute value of x minus 4 is less than delta, will imply that x minus 4 is less than 1 greater than negative 1. Now, if we manipulate that x minus 4 expression a bit, we can get some measure of control over 3x plus 11. Very simple how. We can add 4 across the inequality, which will give us 3 less than x less than 5. We can multiply by 3, so 3 times 3 is 9, less than 3x less than 3 times 5 is 15. And that would give us 20 is less than 3x plus 11 is less than 26. Now, that definitely tells us that the absolute value of 3x plus 11 can be no larger than 26. In fact, we can say the absolute value of 3x plus 11 is less than 26. Okay, what that means is, from our work on line 3, the absolute value of 3x squared minus x minus 44 is less than delta times 3x plus 11, but as long as we suppose that delta is less than 1, then the absolute value of 3x plus 11 will be less than 26, which means this last quantity will be less than delta times 26 delta. Again, if this is the quantity we want to equate to epsilon, that would tell us that delta should be epsilon over 26. Okay, let's write our formal proof. Given an arbitrary epsilon greater than 0, let's choose our delta. Now, what does delta need to be? It needs to be at least as small as epsilon over 26 to make this last part of the proof work. But how did we get that last part to work? Along the way, we had to suppose that delta was less than 1. Well, that means really for this entire piece of scratch work that we've done to work, delta has to be at least as small as both of those quantities. At least as small as 1, at least as small as epsilon over 26. So really, we need to pick our delta to be the smaller of those two to make sure that we're getting a delta that's at least as small as both of them. We'll write that as delta is the minimum of epsilon over 26 and 1. Now if we assume that 0 is less than the absolute value of x minus 4 is less than delta, that will imply that 3x squared minus x plus 1 minus 45 is equal to absolute value of 3x squared minus x minus 44. Again, replicating our work from above, we know that will be equal to absolute value of x minus 4 times absolute value of 3x plus 11. Now, since delta has to be less than or equal to 1, because we've chosen delta to be the minimum of epsilon over 26 and 1, we have by our assumption above that the absolute value of x minus 4 is less than 1. And again, replicating our work from above, that would imply that x minus 4 is between negative 1 and 1. And following our work from above, I'm going to skip a few steps here. We know that will lead to the conclusion that the absolute value of 3x plus 11 is less than 26. Therefore, the absolute value of 3x squared minus x plus 1 minus 45 is less than, well, going back up to the third line of the proof, at the end of the line, we had our f of x minus L factored into absolute value of x minus 4 times absolute value of 3x plus 11. We know by assumption the absolute value of x minus 4 is less than delta, and by what we just proved in the lines above, the absolute value of 3x plus 11 is less than 26. But from the first line of our proof, we have also chosen delta to be at least as small as epsilon over 26. Therefore, we can say that delta times 26 is less than or equal to epsilon over 26 times 26, which is equal to epsilon. Therefore, by the delta epsilon limit definition, the limit as x approaches 4 of 3x squared minus x plus 1 does equal 45.